Alright, so in this video I started doing some experiments with the stepper motor driver with the vortex coil. So I have it spinning at its max speed as I can get it to run, which is around at 39.9 hertz. This is the input voltage and power of it running at the same time of charging the battery. So right now it is charging this capacitor, and then this capacitor is charging into the run battery. So it's consuming 3.5 watts, and the two coils are exactly the same. They're identical to each other, other than one's running one way and the other one's running the other. So one's running clockwise, one's running counterclockwise. We're powering the one that's running clockwise, and we're generating off of the one that's counterclockwise, going into the capacitor back into the battery. This is the output voltage of the generating coil. So now when I disconnect this, you will see the output voltage increase, and the output voltage is greater than the input voltage. Interesting how, because each coil is the exact same length, exact same gauge wire, they're identical to each other, in the other than the fact that they're running in opposite directions. So now without it putting power back into the battery, the power is 3.4 watts being consumed, and the output voltage is still slightly increasing. I have this here to kind of show you a calculation of the output wattage back into the battery. So now I'll put the connector back onto the lead of the battery. So now we're back into generating power back into the battery. So it has increased from the last time that I calculated it. I'll redo the calculation. Sorry for all the background noise in a lot of my videos. It's all the stuff in our basement running. Alright. Let's say 0.2. Calculate. So we got about 0.23 watts being put back into the battery. So technically speaking, we're lowering that back down from what that is by 0.23 watts. I just find it interesting how the generating coil side has a higher output voltage than the input, even though they're the exact same coil, same length, same gauge wire. I'll disconnect it again. See, we're not putting power back in. Voltage is increasing. The wattage is at 3.3 without it self-generating back into the battery. But the cool thing about these vortex coils is, see how the angle of attack on the outside is almost horizontal, and as it gets in towards the core, it flips more towards vertical. So the angle of attack is a lot greater than in the outside. So that, and yet there's still a strong magnetic field in the core of this coil, but it has less interaction with the magnet than it being, if it's something was flat, it has a direct interaction. But now if you put it on an angle, there's not a direct interaction between the coil and the magnet, so there should theoretically be less friction involved, but yet it's still generating a pretty strong field, and plus it just looks pretty. Alright, so now let's just put this back on. And we are dumping power back into the battery. now it's at a greater amount. It's interesting how every time I turn it on and turn it off, the output increases. So there should be a higher output now. So the voltages went down. Let's do 09 because that's about what it is. Now we're at 1865. Nope, we're at 1850. Alright. A little bit more power out. Not much. Gotta love all the ads. Nice. I do have another one of these, but I didn't feel like hooking it all up, and it's in the box yet, so I just thought I'll just do this. Just to show you what the surplus of power coming out of this versus, just running it. It's interesting to see. So the power is kind of fluctuating. It's actually increasing slightly. I'm not sure why it would be fluctuating. Must be something to do with the RPM slightly changing. But anyway, that's it for this video. Kind of just a cool demonstration of what's with these vortex coils, of how can one side be greater than the other.